All right, today we're going to talk about a belief that's so deep, so fundamental, that most of us never even think to question it. This is what the physicist David Deutsch calls the mathematician's misconception.
So let's just dive right in with a question that might sound, well, a little bit silly. Is 2 plus 2 equals 4 absolutely, unshakably, 100% certain? I'm guessing you're thinking, yeah, of course it is. What else would it be? And you know what? That's a totally fair reaction. I mean, for centuries, the answer was a huge yes. The absolute certainty of math was kind of like its superpower, this perfect island of logic in a messy world. But what if the story is a little more interesting than that? What if our whole search for absolute certainty in math has actually been pointing us in the wrong direction?
To really get how we ended up here, we need to talk about a common hiccup in our thinking, a sort of rationality misfire. It's what happens when a really good, really smart idea gets stretched just a little too far and ends up somewhere it shouldn't.
The name for this is a meme misfire. Now, when I say meme, I don't mean a picture of a cat on the internet. I mean the original definition, an idea, a concept that spreads. So, a meme misfire is when a good, rational idea gets applied so broadly that it backfires. The starting impulse is spot on, but the final conclusion, it's just off. So, here's how the logic of this specific misfire works. It starts with a fantastic impulse. We should reject supernatural, magical explanations for how the world works. That's basically the foundation of science and reason, right? But then comes the misfire, the overcorrection. We decide to reject all non-physical things, basically assuming that if it's not made of atoms, it must be hocus pocus. And that's a huge problem. Why? Because it forces us to pretend that a ton of very real things aren't real. I mean, think about it. The laws of physics themselves aren't physical objects. The idea of morality or justice isn't something you can hold in your hand, but it has very real consequences. And of course, for a conversation today, numbers. The number 7 isn't a physical thing you can trip over, but it's absolutely real.
This little misfire has basically backed philosophy into a corner for centuries, trapping people between two warring and, frankly, flawed ideas about what math even is. It creates this false choice that most people feel stuck with.
So in one corner, you've got Platonic idealism. This is the view that says math exists in this perfect, abstract world out there, and we humans access it with some kind of special intuition, which gives us absolute certainty. Then, in the other corner, you've got physicalism. This side says only physical stuff, atoms, energy is real. For them, math is just a handy invention, a useful fiction we made up to help us build bridges. So you have to pick. Is math a mystical, perfect truth, or is it a convenient lie?
But what if you don't have to pick? What if it's a false choice? This is where David Deutsch comes in with this just brilliant quote. He says that just because two ideas are in opposition, that does not prevent them from both being completely false. And yep, that's the case here. They're both wrong. There's a third way to think about this that solves the whole puzzle.
And the key that unlocks this puzzle, the way out of that false choice, is a really simple but kind of mind-bending insight. Proof itself is a physical process.
Let's just walk through the logic here. It's actually super straightforward. Step 1, mathematicians prove things using their minds. They think, they reason, they have insights. Obvious enough, right?
Okay, so what is a mind? It's not some ghost floating in the air. The mind is the product of the brain's activity. The mind is what the brain does. It's the software running on the hardware.
And the brain, of course, is a physical object. It's 3 pounds of wet stuff, made of neurons and atoms and molecules. It's a piece of the physical universe, and it has to obey the laws of physics, just like a planet or a toaster.
And that leads us to the big, inescapable conclusion. If a proof is something that happens in the mind, and the mind is what the physical brain does, then the act of proving something is a physical process. It's a specific kind of computation happening on the physical hardware of your brain.
So what does this actually mean for us? Well, if a proof is a type of computation, and all computation needs a physical computer, like a brain, then it inherits the limits of all physical things. And physical processes are never perfect. They're fallible. They're subject to error, which means our knowledge that we get from proofs can't be absolutely 100% certain. We can be incredibly confident, sure, but absolute certainty? That's off the table.
Okay, so if the whole point of math isn't to reach this impossible peak of absolute certainty, then what is it for? What's the real goal? Why are we doing it?
It turns out we've been chasing a ghost.
The true objective of mathematics isn't to build this unbreakable fortress of certainty. No, it's to achieve something way more interesting, way more powerful than that.
And once again, a quote from David Deutsch just perfectly sums up this huge shift in thinking. He says, "Necessary truth is merely the subject matter of mathematics, not the reward we get for doing mathematics." Let that sink in. Math studies necessary truths, sure, that's what it's about, but that doesn't mean our knowledge of them is perfect. Certainty isn't the trophy you get for finishing the race.
So, what is the prize? What's the real reward? It's one single word: explanation. The whole point of doing mathematics is to create better, deeper, and more powerful explanations about the abstract world of numbers and patterns.
So this gives us a totally new and, I think, much more exciting way to look at everything. Let's recap this new paradigm. 1. Mathematics is the study of real, objective, absolutely necessary truths. 2. But our knowledge of them, which we get through proof, is always fallible because it's a physical process. And 3. Therefore, the real goal is to create better and better explanations about why this abstract reality is the way it is. This idea, reframing math as this creative, explanatory, and deeply human process, is so powerful, and it leaves us with this final, really provocative question to chew on. What other things in our world, what other certain truths that we hold on to so tightly, are actually just our best explanations, for now?